Hi, I'm Kesridhar studying Ashankar Institute of Technology CSCA section. I am explaining about topic is schema refinement. Schema refinement. The schema refinement refers to the refine the schema by using some technique. The best technique of schema refinement is decomposition. Normalization of schema refinement is the technique of organizing the data into the database. If the systematic approaches of decomposing tables that eliminate data redundancy and undesirable characteristics like insertion, update, and deletion analysis. Redundancies refer to the repetitions of schema data or duplicate copies of a same data stored into the different locations. Anomalies. Anomalies refers to the problems occurred after poorly planned and unnormalized database where all the data is stored on the table, which is sometimes called in flat file database. Anomalies are problem facing without normalized problems due to redundancy. Anomalies refers to the problems occurred after poorly planned and unnormalized database where all the data is stored in one table, which is sometimes called a flat file database. Let us consider such type of schemas. SID is sname, CID, CNAME, FEE. Show the table. Next, here all the data is stored in a single table which caches redundance of data or say anonymous as SID and schema sname and repeated ones of the same CID. Let us discuss anonymous one by one. Due to the redundancy of data, we may get the following problems. Those are insertion analysis. It may not be possible to store some information unless some other information is stored as well. Redundant storage. Some information is stored in repeatedly. Update analysis. If one copy of redundant data is updated, then consistency is created unless all redundant copies of data are updated. Deletion analysis. It may not be possible to delete some information without losing some other information as well. Next is problem in updation anomaly. If there is updation is fee from 5000 to 7000, then we have to update fee column in the following rows, else data will become inconsistent. Show the table. Next, insertion anomaly and deletion anomaly. The anomalies exist only due to the redundancy, otherwise they not exist. Insertion anomalies. New courses if introduced C4 but no student is there who is having C4 subject. And show the diagram. Null because of insertion of some data. If it is to phase to insert some other dummy data. Deletion anomaly. Deletion of S3 student caches deletion of course because of deletion of some data forced to delete some other useful data. Show the table. Next, solutions to anomalies, decomposition of tables, schema refinement. They show the diagram. Definition anomaly removed update anomaly removed, insertion anomaly removed. There are some anomalies is in the again. Anomalies in this again. Show the table, update anomaly, deletion anomaly as C2 course is allotted to some students. A student having no courses is enrolled. We have to dummy data again. Next, what is the solution? Solution decomposing into the relation as shown in below. To avoid redundancy and problem due to the redundancy, we use to refinement technique called decomposition. Decomposition process is decomposing a large relation into a smaller relations. Each of smaller relations contain subset of attributes of original relation. Functional dependencies. Functional dependency is a relationship that exists when one attribute unique determines another attributes. Functional dependency is formed of integrity constraint that can identify schema with reductant store problems and to suggest refinement. A functional dependency A gives rise to B in the relation holds true if two tuples have the same value of attributes A also have the same value of attributes B. If T1 into X equal to T2 into X, then T1 into Y T2 into Y. That is T1, T2 are the tuples and X and Y are the attributes. X and Y. They show 1, 2, 3, 4. 1, 1, 2, 4. Next will be X, Y. X equal to 1, 2, 3, 4. Y equal to 1, 1, 2, 4. X 1, 2, 3, 4 to Y 1, 1, 2, 3, 5. The given solution. Functional dependencies. Rename roll number, name. They show the problem. Next is reasoning about the functional dependencies. Armstrong axioms. Armstrong axioms defines as the set of rules in reasoning about functional dependencies and also infer all the functional independencies on the relational database. Type of functional dependencies: trivial, non-trivial. Type of the functional dependencies: trivial functional dependencies if x bar equal y is functional dependency where y subset y x. This type of FD is called as a trivial functional dependency. Non-trivial functional dependency and y is not a subset of x and y is called non-trivial functional dependency. Completely non-trivial functional dependency if x is y and x y equal by then if called completely non-trivial functional dependency. Armstrong axioms, rules of inference rules. Primary axioms. Axioms of reflexibility as if A is the set of the attributes and B is a subset of A and A holds if B is C. A bar equal to the prototype of trivial properties. Next, Armstrong axioms. Next, axioms acknowledgement. A bar B holds to Y attributes. AY gives rise to BY also holds that adding to the attributes depends into does not changes the basic independencies. If A bar B AC B bar BC if any. Next is axioms of transitivity. Same of this transitivity rule is algebra if A bar B holds into B bar C. AC is also holds B. AB is called as a functional that into the B determines B, XY and YZ. XY. RAM is slided to system. SAM is slided off. RAM is sibling of Mohan. Secondary of driven axioms union. If A B holds and A C holds, then A equal to B C holds X Y X bar Z X bar Y Z. Roll number, name and roll number, marks, then roll number, name and marks. Secondary translation decomposition. Next pseudo transitivity. Secondary or driven axioms composition. Candidate key is a minimal set of attributes of relations which can use to identify a tuple in a queue. Consider student table, student student numbers, S name, S phone. As we can take this number as candidate key. We can have more than one candidate the key in table. Type of candidate key simply having only one attribute. Composition having multiple attributes as the candidate key. Next is attribute closure set. Attribute closure as an attribute set can be defined as set of attributes which can be functional determined for it. Note: to find attribute closure of an attribute set, add element of attribute set of to result set. Recurrently add elements to be result to such as can be functionally determined for the elements of the result set. Attribute source: to find all the candidate key present in the relation we needed to find attribute closure. We can find candidate key using the Armstrong axioms rules, but that would be lengthy process and difficult. Thank you for given opportunity.